it is Ms. Martins, and I'm going to explain to you why the answer key is the way it is. If ever I need more than what is already on the answer key, I'm going to use this little online whiteboard here. So coming back to the test, we're going to start with question 1. So it says if the a value in standard form is negative, then the parabola contains a maximum value. Well, if a is negative, that means it opens down, and if it opens down, there's going to be a maximum. Okay, so there's the logic behind that one, so that's true. Okay, next question, number 2. It says that the equation y equals 2 times x plus 3 has one real x-intercept. Well, I think we can all agree that if we expand out this so that instead of having an x all by itself, we write it as x plus 0, we can see pretty easily where the two x-intercepts would be. There'd be one at 0 and one at negative 3. The problem is a lot of people forget that this x even exists, and then they treat it like a linear function. So you want to be really careful with that one. And if it helps, expand that x to become x plus 0, and it'll make it really clear what's going on. Okay? Number 3, the set of imaginary numbers is closed under multiplication. Well, I gave you some complex numbers, a plus bi and a minus bi, because those are called complex conjugates, and we know that the I terms fall out when you do complex conjugates. However, if you want an even easier example, you could think of the example of I, right? Because I is an imaginary number, and when you multiply I times itself, the answer is negative 1, which is real. So clearly, it's not closed, because if you start with two imaginary numbers, the result is not imaginary, right? When we talk about closure, if you put one kind of number into an equation, you should get that same kind of number out. That's what it would mean to be closed. But since that's not true, it's not closed. Okay? Number 4, the range of a quadratic function is all real numbers. Okay? I'm going to just use this tool right here to give us some kind of frame of reference. Okay? Here is my x and y axis. Okay? And here's a function. Okay, the range basically says what are all the possible y values. So basically, we're looking up and down, and we're trying to say what's possible in terms of y coordinates. Okay, well, as you can tell, this y coordinate is never going to be lower than this vertex right here. So that means that the range is not all real numbers, because we're excluding, and I'll use a different color for this, maybe black. We're excluding all the y coordinates down here. So, with that said, the range can't be all real numbers, but the way the question's worded, something does need to be all real numbers. Well, think about what goes with range often. It's domain. And when we think of domain, domain is the set of all x values. Okay, and so I'm going to erase this so that way you guys can focus exclusively on the x values right now. And you can see that left to right, okay, there's no limit to where the x coordinates can be. Okay, they're going to go forever to the left and forever to the right, so therefore the domain is all real numbers. Okay, number 5, if the discriminant of a quadratic equation is 0, then the function has a vertex on the x-axis. Well, there's 3 options for the discriminant. It could be greater than 0, equal to 0, or less than 0. Okay, when it's greater than 0, you have 2 real solutions. That means 2 x-intercepts. When the discriminant is less than 0, that means you have 2 imaginary solutions and no real intercepts. Okay? And when it equals 0, that means that the function does have a vertex on the x-axis. It sits there once. Okay? So this is an image of what that would look like. Number 6, in vertex form, y equals a times x minus h squared plus k. K represents the y-intercept. Well, in vertex form, h and k actually represent the vertex. So you want to be careful here. K does not represent the y-intercept. It depends on where that vertex is located. K is always going to represent the y-coordinate of the vertex. Okay? I think if you do confuse that, remember that plus c in standard form is the y-intercept. So plus c and plus k are 2 different representations, so try to categorize those differently in your mind. Number 7, the absolute value of 2 plus 3i is 13. Well, remember, absolute value is basically asking for the hypotenuse if you were to graph this, right? And each of the legs is going to be 2 and 3. And when you plug it into the formula, you're going to drop the I. That was the most common mistake I saw in our quiz. So we're going to take a squared plus b squared, and then we're going to square root it to solve for c. 2 squared plus 3 squared gets you 4 plus 9, and 13 should be the answer. Okay, but notice that 13 is inside the square root. We still need to keep that value because the square root of 13 and 13 are two different values. So technically this is false because the radicand is 13, but the actual answer is root 13. Okay, so be careful there. There's a numbering issue here, so we're going to repeat 6 and 7, but we're going to do it with the graphing questions. Okay, so given the quadratic, provide at least 3 points on the graph, use proper formatting. So please read these directions really carefully on the test because you don't want to lose points for silly things like this. If ever you write a point, any intercepts, they should be written in the form xy. Okay, if you have an equation for the axis of symmetry, make sure it gets the form x equals h. If you have a question marked with an asterisk, show how you got your answer. Okay, so here we have the graph y equals negative 2/3 x minus 2 quantity squared plus 1. And so I'm going to think to myself, first of all, what kind of form is this? Because that's going to help me figure out what strategies to use. So it looks like it's a times quantity x minus h squared plus k. So I think that's vertex form, which means it's going to be really easy to find the vertex, and that's the first thing I want to do. So I know that in vertex form, this is not what it looks like. So negative 2, flip it, it's going to become positive 2. And k is what it looks like, so plus 1. So I know that my vertex is going to be at 2, 1. Okay, and you can see that right here. Okay, and I would just plot that point. So at 2, 1, and then the other good news is that that also indicates that you have an axis of symmetry going through the vertex. So as you can see right here, I have over 2, up 1, and I've drawn the axis of symmetry up and down through it. Okay. Now, nothing else is particularly convenient. Notice that we have a dilation of 2/3, right? So that's a little inconvenient to do just by guess and check. So I think we're going to want to plot a point. That would make the most sense. One thing we do know is that since we have a negative sign out here, this thing's going to open down. So that's going to be a nice way to check to make sure we didn't make any algebra mistakes, okay? At the end of this all, we should have a parabola that opens down. So to find the y-intercept, that makes sense to be the next point we find since we have to find it anyway. Well, the y-intercept basically says when x is 0, what is y? So we can use this equation plugging in 0 for x and then solving for y, and that's exactly what I did. So this equation is completely identical to this first equation up here, except for instead of an x, I plugged in 0, and then I evaluated according to the order of operations. So first things first, we're going to do parentheses, and we're going to evaluate that 0 minus 2 is negative 2. Then we're going to do exponents, and we're going to take negative 2 and square it, and we're going to get positive 4. And that's where this 4 came from, the first two steps of PEMDAS. Okay, then we're going to do a multiplication. We've got negative 2/3 times 4. Okay, that's 4 over 1, so we're just going to multiply across, and we get negative 8/3 plus 1. We just need a common denominator to figure out what the y-coordinate is going to be. So negative 8/3 plus 3 over 3 is going to get us negative 5 over 3. And even though this is a totally legitimate answer, and notice I wrote it as an improper fraction over here, I translated it to a mixed number just so that I could graph it easier. Okay, and if I don't have any scale on my graph, I'm going to assume we're counting by ones. Okay, so I plotted it right about here. Okay, if you want to change the scale, you are more than welcome to, and that's the reason I put these blank graphs here. But please mark exactly how you are changing your scale. And remember that you can change the scale differently on the x and y axis, which is what we're going to see in the next problem. Coming over to number 7, taking a look at this problem, okay, kind of just looking at it with fresh eyes, we have y equals negative x minus 2 times the quantity x plus 4. I'm looking and I'm just thinking to myself, what form is this? Okay, I can see that it's in factored form or intercept form because those two words mean the same thing. So I know that I have an intercept at positive 2 and an intercept at negative 4 because both of these are the opposite of what I expect them to be. Okay, this negative sign out here indicates that it's going to open down. So I'm just going to plot those 2 points first. Okay, so I have negative 4 out here, negative 1, 2, 3, 4, and then positive 2 up here, 1, 2. Okay, so with that said, with my 2 intercepts, I now really want to find the vertex. Okay, remember the vertex is always going to be halfway between these two. So if I take negative 4 and 2 and I average them, that's going to tell me where the halfway point is. You could do this visually by noticing that if you count in 3 and in 3 you get halfway there, sometimes the numbers won't work out so well. So you can use this formula for the average. -4 plus 2 divided by 2. And when you simplify, you should get -1. And that means that the x-coordinate of your vertex as well as the axis of symmetry are going to be located here. Now, in order to find the y-coordinate of the vertex, we have to just plug in -1. Essentially, we have to find the function at -1. Well, basically, I can just look at my original equation. Wherever I see an x, I'm just going to plug in -1. So I have -1 minus 2 times -1 plus 4. Okay, so I'm evaluating inside the parentheses first according to PEMDAS. -1 minus 2 is -3. -1 plus 4 is 3. -3, right? Opposite of a negative is positive, so I have 3 times 3 is 9. Okay, so that helps me find the y-coordinate of my vertex. So I have -1, 9. Notice that won't fit on my graph, so that's why I decided to count by 2's. Okay, so then I put that right about here, just above 8. Okay, and at that point, I actually have enough information because I only need 3 points. Okay, my axis of symmetry is always the x-coordinate of my vertex, so -1 should match -1 up here. To find the y-intercept again, okay, the y-intercept is formed when you figure out, well, if x is 0, what's y? So I did the same thing that I did over here, except for instead of plugging in -1, I just plugged in 0. Okay, so I have negative parenthesis 0 minus 2. Again, I'm identical to my original function, just plug in 0 wherever I see x. 0 minus 2, 0 plus 4. I'm evaluating inside the parentheses. I've got -2, I've got positive 4. Again, my two negatives cancel, and I have 2 times 4 is 8. So that helps me figure out the y-coordinate. And I always want to see the y-intercept x comma y because I really want you to understand where it's located on the graph. I don't just want an 8 floating around, okay? 0 comma 8 gives me a very clear picture of what you understand that x-intercept to be. So far, so good? Awesome. Let's keep going. Error analysis. Describe and correct the error in graphing the function f of x equals x squared plus 4x plus 3. Follow the error through the remainder of the problem so that all information is correct. So let's take a look at the original problem without my answer. Okay, we've got the axis of symmetry is x equals b over 2a. Holy cow, I can already tell something's funky because this person is using the wrong formula. Okay, it should be x equals negative b over 2a. And remember, that comes from the quadratic formula, x equals opposite of b, and then you've got plus or minus square root, we've got the discriminant, all over 2a. So if ever you forget that formula, come back to the quadratic formula and discount the discriminant. So with that said, it's going to be negative b over 2a. So that's one issue already, okay? So let's see, the b value is 4. That looks good. And then the a value was 1. Yep, there's a hidden 1 in front of the x squared. So it looks like the axis of symmetry is actually going to be -2. Okay, and so I calculated it over here. I have -4 over 2 times 1. And yes, I got -2. The issue is that that's going to have a trickle-down effect for this graph. Okay, so instead of plugging in f of 2, we actually need to plug in f of -2, which is what I'm doing over here. So I have -2 squared plus 4 times -2. Make sure you're plugging -2 all the way through. And we've got to follow our order of operations. We get that this is 4. 4 times -2 is -8. Okay, this gives us -4 plus 3, which is -1. So we combine our x and our y value to make the coordinates of the vertex, and we've got -2 comma -1. Okay, the y-intercept should be 3. Okay, that's actually correct. So that's not an issue from the graph because you could tell that from the original. Okay, so the points 0 comma 3, okay, which is on the left, and 0 comma 3 is on the right, and -4, 3 is on the left of the vertex. And one thing I didn't put in here, which might be helpful, is a new sketch. So I'm going to just pull that up on Desmos right now so that you can see what the graph should look like. And I'm going to scoot this down so we can read what the question was. X squared plus 4x plus 3. Okay. And you can see here's that -3. Let's see. Oh, here we go. Okay. So 0, 3 is the point on the graph, right? That's what we found here. And then if we reflect that over the axis of symmetry, okay, we're going to wind up right over here, which is -4, +3. Okay, and those lie on the graph. This thing opens up, not down. And by assembling all this information together, you should get this graph. Okay, continuing on. It says, write a quadratic equation in standard form, and it gives you standard form that meets the specified conditions. Perhaps you might consider writing the equation in one form and then converting it to another form. So basically you want to ask yourself what is most convenient. Well, if I know the vertex and I've got some stretching and I know which way it opens, it seems very clear that I'm going to use vertex form. Okay, so I know that my vertex form is a times quantity x minus h squared plus k. So for A, I need to include any dilations and any reflections because those together make up that coefficient. So I have a factor of 2, which means A is going to be 2, but since it opens down, I have to tack on a negative. Okay, so that means that A is going to become -2. For H, it's the x-coordinate of the vertex, so that should be 3. Okay, when I plug in 3 for H, that minus sign is going to get carried down. Okay, so x minus 3. And then for -10 for k, okay, I'm going to have plus -10, which we can simplify just to -10. Okay, so now I have an equation in vertex form that includes all of this information. And what makes sense now is to transform it into standard form. So I have x minus 3 squared. I want to do my order of operations, and so I need to do my exponents before I start multiplying and adding and subtracting. So I'm going to expand this to be x minus 3 times x minus 3. I'm going to FOIL, and I think I'm going to get x squared minus 6x plus 9. I've got -2 multiplying outside of it, and I've got subtracting 10 on the other side. So I want to distribute this -2 into all three pieces, and I'm going to get -2x squared plus 12x, because those minus is going to be a plus. -2 times 9 is -18, and then I have to make sure I bring down that -10. Okay, these two are like terms because they're constants, so I can combine them, and I'm going to get -28. Okay, and now I have an equation that is completely identical to my original, but it's in standard form like I was asked. Okay, scooting on to number 10, we have zeros at 2 and -5, and it opens up. Okay, it doesn't give us any information about a dilation coefficient, so you're welcome to add one in or not. That means that number 10 has many correct answers. In fact, it has an infinite number of correct answers. However, that also doesn't mean that every answer is correct. So let's take a look at one possible correct answer. This means that we have an intercept at 2 and an intercept at -5, which means our factors are going to look the opposite. Okay? X minus P, X minus Q, where these are the intercepts, and that minus sign means it's going to look like the opposite of what we expected to. So if we have a +2, it's going to come in right here for P, and that minus sign gets carried down. Here I have -5, and when we subtract a -5, it simplifies to +5. Okay, so this is my equation in intercept form. It opens up, so if I just leave this as a hidden 1, that's going to force it to open up because 1 is still positive. So you don't have to add a coefficient here, but you're welcome to if you'd like. As long as your coefficient is positive, you will have a correct answer. Okay? So converting this to standard form, we simply FOIL. Okay, first outside, inside, last. Combine your middle terms. 5x minus 2x is 3x, and voila. Okay? If you're unsure about why this works, graph these babies and then compare them against the criteria that they're supposed to have and confirm that that's true. Okay, you may not have that luxury on the test since this part is no calculator. However, while you're at home and you're trying to make sense of everything, it's a great idea to confirm your answers with a graphing calculator so that you're building that mental imagery that you can then access on the test. Continuing on, for 11 through 14, it says solve for all roots by any method. Again, roots, solutions, intercepts, they all mean the same thing. So I've tried purposefully to use different vocabulary and make sure you're comfortable with all of them. But just make sure that you know whenever you see any of those words, they're synonymous. It says you may use each method exactly once. That means that you probably want to figure out which ones are more specific, which strategies only work for certain kinds of problems, and get those out of the way first. For example, quadratic formula and completing the square, they work with literally any type of problem. So that's why I have these numbered here, is because I wanted to start with the ones that don't work with any kind of problem. Okay? Lastly, it says be sure to fully simplify any answers, leaving imaginary answers in terms of I. So first things first, in order to use the square root method, we have to make sure that there's no middle term with x. That will actually disrupt our ability to use the square root method. So I'm going to look around and I'm going to try to find an equation that doesn't have an x term, and voila, here it is. Okay, so since there's no x term, I can use the square root method. Okay, what I want to do is I want to scoot this 140 over to the other side so that I have an x squared equaling a constant. So subtract 140, subtract 140, we get 7x squared equals negative 140. Let's divide by that coefficient of 7. Okay, we're using reverse PEMDAS. And then we get x squared equals negative 20. Well, to get x all by itself, we just undo the squaring with a square root symbol on both sides. But remember, that introduces a plus or minus. So we're going to have the square root of 20. I'm going to just pull out that square root of negative 1 and write it as I. And now I can focus only on the numeric part. And I'm going to simplify square root of 20, looking for a perfect square that goes nicely into 20, which is 4. And I've got root 4, root 5, and that simplifies to 2i root 5. Okay, don't forget that plus or minus, that got carried down from here. Okay, so that's one of them. And once I've used it, I'm crossing it out, so goodbye. And I want to look for something that can be factored, okay? Because not everything is factorable, as you guys knew from Algebra 1. So, and I look at number 11, that might be factorable. In fact, I could pull out a 2 to make that easier, okay? And that would give me x squared minus 5x minus 14. That one seems pretty plausible that it could be factorable. I chose number 12, x squared minus 2x minus 8. But I think either of those should work. So with that said, here's the way I did it. I looked for two things that multiplied to negative 8 after I rewrote this in standard form. It's really important that it equals to 0 before you factor. So I looked and I got negative 4 and positive 2 multiplying to negative 8, and conveniently they add to negative 2, which is what I need. So I've got x minus 4 times the quantity x plus 2, that equals 0, and I'm looking for the values of x that satisfy the equation. Well, if either of these factors equals 0, 0 times anything will be 0. So if x is 4, we've got 4 minus 4 equaling 0, that's good. If x is negative 2, I know that negative sign's a little hard to read, so I just wanted to point that out and make sure you see it. Negative 2 plus 2 will be 0, and then 0 times anything will be 0. Okay, so now we've done some factoring. The good news is that completing the square and quadratic formula will work for literally any problem. Now, for number 11, I made this a little harder than you need to, okay? What you could have done is you could have divided by 2 right at the beginning, and that would have made your life a little bit easier. So you are more than welcome to do that, okay? I pulled out the 2 here at the beginning, and I scooted the negative 28 over to the right. And that left x squared minus 5x, and then I actually had a blank here, okay? Half of b is negative 5 halves, and square it becomes positive 25 fourths, okay? But I just arbitrarily added 25 fourths, not exactly, but it seems like it. I arbitrarily added this quantity into the equation. I have to balance it out. But remember, this 25 fourths is actually getting multiplied by 2. Okay, so 2 over 1 times 25 over 4 equals 50 over 4. So I'm counterbalancing that by adding 50 over 4 over here. Okay, continuing on. Okay, I have 2 times x minus 5 halves squared. I'm just rewriting this trinomial as a binomial squared. And that equals 25 halves. I just divided by 2 along that common factor in the numerator and the denominator. Then I need to add 28 because I really want to isolate this squared term on the left and get it equal to a constant. So I'm adding 28 over here. Notice that I don't have a common denominator right now, so I'm going to make it by multiplying by 2. So 28 times 2 will get me 56. Okay, 56 over 2 is where that 28 came from. And then continuing on, that's going to simplify when I add 25 and 56 to 81 over 2, which is great. 81 is a perfect square, which is going to be convenient later. But I want you to think of the problem kind of ending here and starting over here, okay? This 1/2 is designed to counterbalance this 2. Okay, we want to get rid of the 2, so we're basically dividing both sides by 2. Well, since we have some fractions over on the other side. Instead of dividing by 2, what if we just multiply by a half on both sides? That achieves the same effect. So let's multiply by a half on both sides, and then we're going to be left with, and I'm scooting over here, x minus 5 halves quantity squared equals 81 over 4, okay? 81 times 1 is 81, 2 times 2 is 4, and this is great because when we take a square root, we've got two perfect squares in the top and the bottom, which is awesome. So we're going to square root both sides. That's going to introduce the plus or minus. Never, never forget it. We get x minus 5 halves equals plus or minus 9 halves. Okay, I'm going to scoot my 5 halves over to the right-hand side, making it positive. So now I have x equals 5 halves plus or minus 9 halves. And it may be tempting to leave your answer like this, but there's no reason you can't combine these because they are like terms. So it makes sense to think of these as two separate equations. What is 5 plus 9 halves? Well, 5 plus 9 is 14, and you've got your common denominator, so 14 halves. And 5 minus 9 halves, right? 5 minus 9 is negative 4, and thus you get negative 4 halves. So simplify these two fractions, and you get 7 and negative 2. So again, I made this a little bit harder than I needed to because I didn't factor out the 2 and then divide by 2 on both sides, but you are more than welcome to, and that will alleviate some of the demands of this problem. Okay, so always look for that common factor, which is what I didn't do. Last but not least, quadratic formula. I like to take the messiest one and use the quadratic formula. 2x squared plus x plus 3. I rewrote it in standard form with descending degrees. I figured out my a, b, and c values. I plugged it into the formula. X equals opposite of b plus or minus square root, b squared minus 4ac all over 2a. Please memorize this. Remember that here's your discriminant, and here is your equation for the vertex. So if you put those two together, you get the quadratic formula. Okay, I'm just plugging in. B is 1, so the opposite of b is negative 1, plus or minus square root b squared. Well, 1 squared is just 1, minus 4a, which is 2, c is 3, all over 2a, which is 2 times 2. Continuing on, this here simplifies to 24, so I have 1 minus 24, which gets me negative 23, which means I'm dealing with an imaginary solution. Okay, so I'm pulling out that negative piece and I'm rewriting it as I. Okay, I root 23. Now, I highly recommend you write i's out front because a lot of people are putting I inside the radicand on their quiz. And remember, I already has a square root in it. I is defined as the square root of negative 1, so you don't want to be taking the square root of the square root. So putting the I out front is a really good idea. Okay, there's nothing more you can do except if you wanted to write your answer in a plus bi form, you could split this 4 up to both pieces, but I don't think the directions ever said it anywhere. Okay, it just said leaving imaginary answers in terms of I, so you don't have to. This would be a totally valid answer. Number 15, convert the following equation to vertex form. Y equals a times quantity x minus h squared plus k. Okay, so I'm basically sending the negative 7 off to the right. Okay, and then I've got 2 times x squared plus x, right? I've factored out that 2, so that leaves behind only an x squared and only an x. And then this is a blank at this point that I want to fill in. So to figure out what goes here, we half of b, which is 1/2, and square it. 1 squared is 1, 2 squared is 4, okay? But remember, did I really add 1/4 of an orange into this equation? No, okay? 2 times 1/4 is 2/4. Okay, but since I'm operating on the same side of the equation, I don't want to add another 2/4 because then it's just going to make it even more out of balance. I want to undo what I just did. So if I added 2/4 in, I've got to subtract those 2/4 back out. Okay, and I purposefully left this unsimplified just so that it would match this. Okay, we can always simplify later, which is what I do right here. This is negative 1/2. Okay, so now I have my 2, which comes straight down. I rewrite my trinomial as a binomial squared. Remember that this piece, okay, comes from here. And let's see, it looks like there's a mistake because it looks like this should be positive 1/2 and this here should be positive. So I want everyone to change this minus into a plus. Okay, I know I can't do it on my screen, but I see that mistake right here. That's going to be x plus 1/2 squared minus 7. Then I need to combine these like terms, okay, and we need a common denominator here, so 7 is going to turn into 14 halves. Negative 14 halves plus another negative 1/2 is going to get you negative 15 halves, okay? And your final answer should be y equals 2 times the parentheses x plus 1/2 squared minus 15 over 2. Okay? Questions? Continuing on. Number 16. We have I to the 51 plus 4I to the 30 minus I to the 99. So whenever you have these really big exponents, you want to divide by 4 and look at the remainder. Okay, so let's start with 51 divided by 4. Okay, I don't even care what the quotient is. I care what the remainder is. The remainder is 3. Okay, well, if the remainder is 0, remember I to the 0 is 1 because anything to the 0 power is 1. I to the first power is I. I squared is negative 1 because that's what we defined I as, the square root of negative 1. And then I to the third power is negative I. Okay, and then once we hit 4, it starts repeating back. So notice that this 4 heads back to 0 because when you have a remainder of 4, right, that would mean that you have another group of 4 to go in. So when you have a remainder of 3, that means that the answer is negative I. So I to the 51st power would simplify to negative I. Then we have 4 times I to the 30th. Well, we take 30 and divide by 4, we get 7 with a remainder of 2. That means that we're dealing with negative 1, but don't forget that coefficient. So we have 4 times negative 1, which is negative 4. And then we're going to subtract out I to the 99th. Okay, 99 divided by 4 gives me a remainder of 3 again. So remainder 3 says negative I. So I'm subtracting a negative I, and that minus minus turns into a plus. So I have negative I plus I. Those cancel, leaving behind negative 4. Number 17. Okay, we had a problem similar to this on your quiz, but this one's actually a lot easier. The first thing you're going to do is distribute the I. So I have 9I minus 2I squared, and I know that I squared can be simplified, so the best thing you can do is simplify early so that you reduce the amount of simplification you have to do later. So I have I squared being negative 1, 9I minus 2 times negative 1 over 2 plus 3I. Looks good. Let's simplify this piece right here. It's going to get me plus 2, which is right here. 9I plus 2 over 2 plus 3I. Okay. In order to tackle this, we now need to multiply by the conjugate, which is 2 minus 3I in the top and the bottom. Okay. So my numerator is going to be 18I minus 27I plus 4 minus 6I. Okay. And then using properties of the conjugate, we should get a real denominator. So I have 2 times 2 is 4. My OI terms are going to fall out. And then I have 3I times negative 3I, which is going to get me negative 9I squared. Okay, again, I squared tells me I can turn this into negative 1, so let's try to do that. This negative 1 here is going to make this 4 plus 9, okay? Heading back to the numerator, okay, I rewrote this in a more convenient way by combining terms that are like terms near each other. So I have 4 first, then I put the negative 6a and positive 18i together, so that way I could combine them more easily, and I have negative 27 times negative 1. So this is going to turn into positive 12i. Here we've got positive 27. 4 plus 27 gets you the 31. The 12i is right here. 4 plus 19 is 13. And I don't see any common factors between all three of these numbers. Therefore, there's nothing we can simplify. Okay, continuing on. 3 minus 2i minus negative 11 minus 9i. You have to remember to distribute that negative sign. So when I distribute the negative, minus minus turns into plus. Minus minus turns into plus, and I combine like terms. So I have 3 plus 11 giving us the 14, and I have negative 2 and 9 giving us the 7i. Number 19. The sum of two complex numbers is 8 minus I. Well, the sum is the answer, so that's why I put this over on the right-hand side. Given that one of the numbers is 11 minus 3i, what is the other number? Okay, well, we're basically asking ourselves 11 plus what is going to give me 8? Okay, because this and this are going to combine together to get me this. That's the real part of my complex number. Well, 11 plus what number gives me 8? If you subtract 11, you get negative 3. You can kind of do this in your head too if you want. And the same thing's going to be true for the I terms. Negative 3 plus whatever b is going to have to equal negative 1. Okay, so when you add 3 to both sides, b would have to be b would have to be positive 2. So that's another mistake that I see. Okay, it should be negative 3 plus 2i. Okay? So again, for mistakes that I'm finding, it should be negative 3 plus 2i, and then heading back to the top of the page, it should be 2 times parentheses x plus 1 half squared minus 15 halves. So I apologize for those if they confuse you. Okay? Word problem. So again, these probably won't show up on Tuesday's test, but they will show up on Thursday's portion. Okay, so a rectangular garden measures 8 yards by 4 yards. You want to triple the garden's area by adding the same distance to x to the length and the width. So remember that area, okay, we're going to put the A over here. Area equals length times width. Well, the length is going to be 8 plus whatever x is, and the width is going to be 4 plus whatever x is, and the total area is going to be the current area, which is 8 times 4, but 3 times bigger because we're tripling it. So that's how we set this equation up. Now it says solve the equation by factoring and show all steps. So we've got 8 times 4 is 32, plus 8x, plus 4x, plus x squared equals 96, and that was just some nice good old FOILing. Combine our like terms, we get x squared plus 12x plus 32 equals 96, okay? Then what we're going to do is subtract 96 on both sides, so that way we set it equal to 0, and we get x squared plus 12x minus 64 equals 0. We're looking for two numbers that multiply to negative 64 but add to 12. We've got 16 and negative 4, which do the trick. So x would have to be negative 16 or x would have to be positive 4. Okay. The issue is that we're not going to add negative 16 yards because notice we're starting with 8 and 4. That would be outrageous. So 4 is the only one that makes sense. Okay. So what are the new dimensions of the garden? You should have 12 yards because 8 plus 4 is 12 and 4 plus 4 is 8. Okay. Wherever it says include units of measurement, make sure you give me that answer so I know what you're thinking that your answer actually represents. I really want to make sure that you contextualize your results because that's where the math really gets meaningful. Number 21, a campground rents campsites for $12 per night. At this rate, all 90 campsites are usually rented. For each $1 increase in the price per night, about 3 less sites are rented. The campground's nightly revenue can be modeled by R equals 90 minus 3x times 12 plus x. Find out how the campground can maximize nightly revenue. Show your work. So when I see this word maximize, it makes me think vertex. Anytime I see maximize or minimize, that's what I'm thinking automatically. And notice that I'm already kind of in intercept form. So the way I chose to do this was to utilize intercept form. So I noticed that this pair of factors here has a common factor of 3. So I pulled out 3 and that gave me 30 minus x, okay? But usually we put x at the, usually we want x to not have a negative sign in front of it, okay? So what I did was I switched the terms, negative x plus 30, okay? And we also switched the terms over here because we're used to having x at the beginning as well. So there was a lot of things that were unusual about this, and I just used some rudimentary algebra operations in order to make it more understandable to me. So again, I switched these terms, remembering that each sign is always attached to the thing behind it. So this negative x is treated as a unit, and it got put in the front. This 30 is positive, so it got a plus 30. And then I have x plus 12. So I just rearranged the order. And then I don't like having a negative in front of x because it doesn't really help me understand what's happening. So I'm actually going to factor out that negative sign and put it out here, which leaves behind x minus 30. So now I have something that I'm really familiar with, negative 3 times parentheses x minus 30 times x plus 12, which means that I have two x-intercepts at 30 and negative 12. So that makes it really easy to visualize, and I know that halfway between there will be the x-coordinate of the vertex. So 30 plus negative 12 divided by 2 gets me 18 over 2, which is 9. And now that I know the x-coordinate of my vertex, I can plug in 9 for x, and I can figure out what the revenue would be. Okay, so 90 minus 3 times 9, again, I'm just taking this original equation, and wherever I see an x, I'm plugging 9 in. And that helps me find the vertex at 1, 3, 2, 3. Okay, so basically it says find out how the campground can maximize revenue. What does that mean? Well, x represents the number of $1 increases. Okay, so basically we figured out to maximize nightly revenue, increase rent by 9 groups of $1 or $9. And when you do that, you're just basically taking the current rate, which is 12, and adding 9 to it. So you should eventually get to $21 per night when you are achieving your maximum revenue. And by setting the price at $21 a night, you're going to achieve a revenue of $1,323. Okay, you will have a calculator for these available to you. However, for problems like this that are factorable and are accessible with algebraic techniques that we've learned, I will be expecting you to show your work even though you can check your answer with a calculator. Continuing on, number 22. Use your calculator to analyze the following problem. Remember, v sub 0 is your initial velocity and h sub 0 is your initial height. So 40 represents this parameter right here, and 315 represents this parameter right here. Strike that and reverse it. 315 feet per second is your velocity, so that belongs here. And then 400 feet high represents your initial height. So I apologize, I switched those order. So with that said, I'm substituting those values in right here. It does look good on paper, even though I said it wrong, so this does look correct. And then it says find a reasonable graphing window through which to view this problem. Consider using the zoom fit feature of your calculator. We talked about how to zoom in and zoom out. So you'll find the zoom fit feature wherever you see that window button, and then the zoom in, zoom out. Zoom fit basically just uses an algorithm to estimate where the graph is, and you probably still need to do a little bit of tweaking. But with that said, it does at least give you a starting point. So what will the maximum height of the rocket be? In this one, I'm just basically calculating the maximum, okay? So I'm using the maximum feature of my calculator to do that, and it tells me about 1,950.4 feet. Notice it says I don't need to show any work, so answer a nice unit of measurement and you're good to go, okay? You could do this algebraically by using the opposite of b over 2a. So since you have a calculator, you could absolutely show your work for this as well. It just says no work needed, so that would just be a little extra. Part D, how many seconds have passed when the rocket reaches its highest point? Okay, so basically that's saying we're still dealing with the vertex because it's the highest point, but x is represented with time. Technically, I think we used t here, okay, but you probably are using x when you type it into your calculator. So basically, when the y coordinate is 1950.4, the x coordinate should be 9.8. Okay, and it says a cloud cover exists at a height of 1,000 feet. Find the range of times at which the rocket will be out of sight due to being hidden by clouds. Be sure to include the lower boundary and the upper boundary in your answer. So basically, we're asking ourselves at what two times is this function intersecting with the function y equals 1,000. So remember in class when we did that intersection feature, okay, we graphed two functions and then we looked for intersection and we put our cursor right here and then we dragged it over here so that it kind of highlighted a rectangular window and then it identified exactly that point of intersection. Well, this point is 2.137 seconds, comma, 1,000 feet. And then if you do that again over to the right side, you should get 17.551 seconds, comma, 1,000 feet. And for the entirety of the time between those 2 points, it should be out of sight, okay? So that's really what that question's asking, for the range of values between about 2.1 and 17.6 seconds, okay? With that said, that is everything. So if you have any questions, please send me an email and I'll be happy to help. Thanks, everybody.